They changed the layer two.
Okay, so Hank, here's the argument. If I get a transparent statement with a bunch of receipts, that doesn't mean I have to look at and address everybody else's receipts as part of my computation that I'm going to generate a own notarized statement ourselves, right? So we've already said that any other existing receipts can be taken out of the computation of what we received, because people want to know that you notarized the original signed statement. Don't care how many other countersignatures are on the message, correct?
Well, when you just to follow that, you're saying you notarize the original statement.
No, we allow you to give a transparent statement. You allow to give a transparent statement or a signed statement, correct?
Let's just not step over each other, because this is going to be important. I'm just clarifying, when you're saying notarize, what position are you taking? Is it just the to be signed bytes of the protected header and the payload, or are you suggesting it should be more than that?
I'm arguing we already have a reason that we want to exclude something if we're already getting a transparent statement on this ledger to generate our own countersignature form. There's already logic that says, hey, you don't look at anybody else's countersignatures.
I'm trying to follow what you're saying, though, because the transparent statement is not something that's in the ledger today. Transparent statement is something we assemble outside the ledger, the way we've defined.
We handed a cozy message with already countersignatures in the unprotected header, correct?
Correct. In the unprotected header, yes. That's the debate we're having here is, what do we do with the unprotected header?
But so that basically means it's no longer just a signed statement; it's a transparent statement, correct?
So I'm because I don't have a strong opinion here, so I'm trying to make sure we're talking the same thing. You're right. When the ledger accepts a cozy sign one message with an unprotected header, that does come in. We've debated whether it should be stripped or not, but you're right, it does come in, and we haven't clarified what should happen to it.
But I'm pretty sure we talked about receiving a transparent statement for exactly this reason, because the order in which I send it off the ledgers to generate receipts shouldn't matter.
Yeah, why would you think that matters? I'm confused. So registering a transparent statement means registering the counter signature of the receipt in the statement at the next TS. So you registered once, make it transparent, take the transparent one, so include it plugged in unprotected header parameters, right? And then you register that at the next one. That's what you're saying, right? No.
Well,
no.
You're allowing it to be flow around the system, but it doesn't mean that you want the counter signatures from the German SCITT instance and the French SCITT instance and the American SCITT instance to change the order in which you generate a receipt.
Pause a second. Can you guys see my screen?
Yeah, we can see.
Okay.
I have not looked at the screen. No. Yes. Okay. So I don't understand why this order is somehow in any way significant. First of all, it's a map.
Because
modeling is irrelevant in maps.
Hold on. Order of the header elements, or the order of transparent statements, or order of statements that come out of the ledger? Which order are we referring to?
We created this when we made the counter signatures an array. The order should not matter.
Oh, I see. You're talking about when receipts are added to the unprotected header. That's the order you're referring to here.
And so if I send it around to multiple instances, can I just daisy chain it and not have the existing receipts as part of the computation of what was seen on the ledger? Like, why does it matter whether it went ABC or CBA?
Okay, well, that's hold on, please.
The reason I bring this up is because if we figure this one out, the second one may be easier.
But I just want to bucket a couple of things, because right now we have not clarified that we do anything with the unprotected header as it comes in. So as hold on, Roy, hold on a second. I'm just trying to help understand what we're discussing here. Are you because now we're discussing in the unprotected header, the order of receipts that in the array. Is that part of this? Is that what you're discussing here?
That's part of the complexity we add by saying, hey, we're not allowed to strip things out of what we save on the ledger. But what's important on the ledger is the sign statement, not existing countersignatures. Omri?
So I just want to say, I think maybe the thing you're missing, Steve, is not the order of the receipts as they're included in the unprotected header that causes a problem that Roy is describing. Is the fact that if you sign over those, if you sign over the unprotected headers, then it changes the to be signed, right? And so then you need to wait until you've done the first registration to the second one and so on. Or if you do like ABC or CBAs, it says, it changes fundamentally what you sign. So it's not how they're populated in the unprotected header. It's the fact that if you sign over that, then it starts to matter. Whether if you don't, then it doesn't matter.
What
and then
do
you
you mean with
you can do it in
sign?
parallel.
When are you signing a transparent statement? Help me here. I don't get
on
it.
registration. Let's
Yeah, but that's not signing. That's registration. Registration is not signing. So when are we signing something? I'm not following.
The notarization, the counter signature that comes out of the transparency service. The transparency service signs something.
Yes, it signs a receipt, and the receipt is not a counter signature.
No, but it signs a proof. Like the receipt is the sign proof, and it is a counter signature, right? And then the receipts, like the thing that is signed is the root of the Merkle tree. And if you put the thing at the bottom, then it matters if you include these things or not, because it changes the root that you're signing potentially, right? I mean, not potentially change the root that you're signing.
Yeah, it would change the hash that you are putting in the tree and then sign the new root with. Yes, that is obviously true. If you mess with the to be registered bytes, the next hash will be different. Okay, that is very straightforward.
I'm sorry, I was looking through the new TOC. Omri, can you? I can go back and listen to the recording, but I'm here. Can you repeat what was just said? Because the signed statement comes in. It's got a complete structure. A receipt is issued. What were you arguing for, one way or the other?
So if you include when you take the digest of that statement that comes in, and then you put it, in your sequence of entries in the leaves of the Merkle tree, which you're later going to sign, and the signature of that is your counter signature. And if you include the unprotected header in that, then it changes the root of the tree. You change the leaf, it propagates up, and then change the roots. You get a different counter signature depending on which unprotected headers you've included. So that means that any prior receipts that you sent, if you sent something that was transparent, which was Roy's point, do influence and change the counter signature that you get. This is, it has, good sides and bad sides. Certainly a bad side means like you can't just submit something to a bunch of things at the same time and get a bunch of things back and then compose your statement and do things this way. Instead, you have to sequentially submit things one by one. You do get something that's kind of like more precise, right? Because it does capture the history or the order in which you did things. Whether that's good or bad is kind of, separate thing. I think my real worry is not so much that, although that's certainly like a problem for these use cases, is also the fact that this stuff is just fundamentally unauthenticated. So I think even the term counter signature is abusive in this case, because counter signature implies that you have signed the thing in the first place.
This is not a counter signature. This is not again, Russ Housley was live on mic and says, this is not a counter signature. That is why we're calling it a receipt, actually. We were starting with counter signature until Russ Housley, the CMS guy, right? Then I was like, this is not a counter signature. You put metadata to the counter signature, therefore it's not a counter signature. Right. Give it a different name. And that's why it's a receipt. So it's very confusing to other people, not us here, if you call it a counter signature, to be honest.
So if the key to look in a ledger is the signed statement.
I heard you multiple times, but you think that's the wisest choice? Because I remember that we are not messing with the to be registered bytes.
We never said anything about whether we saved the whole content or what we put into the ledger. And the ledger to me is only the signed bytes. That
is a viable choice. I'm not entirely sure if the typical attendees of this call would agree with that. I'm thinking Ori first, and then John next. Actually, I don't know. I don't know how John thinks about it, but I assume that Steve knows. So,
because you get into this problem from an audit point of view. If I have a signed statement or a transparent statement where the X509 chain has been removed for size reasons, it should still be valid that you can go and audit it and find it on the ledger.
all valid arguments that have to be captured. We have to need a procedure like in COSI where you produce the to be signed bytes. We have to say that we need the same procedure. And if it's just a sentence that says stripping unprotected always to 0, empty map done, that's a.
It's also a payload.
No,
it's protected and payload.
What?
The to be signed bytes are protected.
There is to be signed, exactly. We need a procedure like the to be signed procedure as defined by COSI here in the SCITT architecture, where we do the registration procedure, and the registration procedure has to tell us, like the COSI document tells us how to be signed works, how our to be registered works. And there must be a default rule for that, I assume. Otherwise, it's super arbitrary. And the default rule could be that you strip certain things from the header, or from protected header, or strip all the things from the unprotected header, or, for example, always add something to the unprotected header, such as a timestamp, which was in discussion at some point.
I really don't see you have to strip anything, because all you're doing is taking the signature hash, and that's your key into the ledger anyway. Like it's already been done for you. You don't have to strip anything.
No,
signature hash is a little hard to. I mean, so yeah. I'm sorry, Armin, you go ahead. Let's do the raising hands because this is a heated one. But go ahead, Armin.
Sorry. Like the tooling, the stuff that's out there, all the libraries that you have do not let you extract the to be signed hash from one of these things, right? It is not possible to do that. So you have to take, or you don't have to, but I think it'd be wildly easier if we take something that's already available in the libraries that exist, if we expect that people are going to be writing validators and things to do with that. So either we can, take the whole statement, strip the unprotected headers, and digest that. You could digest the signature, you're right, add one more digest, but grabbing the to be signed digest, although like it's the correct pure thing to do because it's the thing that signs, that would be like the closest thing to, well, I'm not going to say counter signature, but then like this is really inconvenient to do because like none of the libraries that exist out there let you extract this easily from a message. So we need to look for one of the options that's practically usable by people who write validators and stuff like that today, I think.
That's a good point. So that the to be signed bytes are internal typically for libraries because they were not assumed to be interesting to the outside caller. Makes this difficult. You could, of course, always re-implement it. So it's not a huge deal to recreate to be signed outside standard library interfaces. But yeah, I see that this is a hassle a little bit. I'm not entirely sure how hassly the hassle is, to be honest. But the real thing to say here is to what the recommended way is and define the default, and that deviation from the default must be specified by TS accompanying text, I don't know, profiling of SCITT, whatever. And then it's okay. It just has to be reproducible and interoperable. That's all on my part. If we come down to arguments like the order in the array of receipts in the unprotected header has a meaning, that feels like a very deep rat hole. I don't know if there's agreement there possible, but one could try. And again, I heard that adding a timestamp felt like a cool idea to some. They would even mess directly with the unprotected header and would not allow to even use the to be signed bytes, and that would be, if you can get at them, be useless. So I don't know where. As what I'm hearing is to just recreate the to be signed bytes and then to hash that. Is that correct?
Look, the problem I've got here, Hank, is given a signed statement in the wild that can have arbitrary unsigned headers added, there's no way to know how to get back to you.
Yeah. I'm fueling your minute here with water. So what I said is the to be. Yeah.
In our implementation, we just drop the unprotected header to get a consistent content identifier for the signed statement. We just take the unprotected header. We say whatever's in here, I'm throwing it away. I'm reserializing and I'm taking the hash of the entire object.
That's what I argued.
Yeah, and I tried to put on your hat because I remembered verbatim saying you don't mess with the bytes. But it's fine. If that is the consensus, you're absolutely A-okay. I tried to represent what you said a half a year ago, Ari, and I obviously failed hard representing you here. So
Ori can be crystal clear in his words. Let me just clarify that, because it's the to be signed bytes are protected at payload. Are you saying we're also hashing signature?
Yes, in my implementation. If
Okay.
you just take the to be signed bytes by themselves, you're not including the signature, and then you have
That's
nothing that's verifiable that's in the hash.
That's fair.
So
Okay, so this
you take
goes way
the-
back to Cedric or Antoine's argument to
Oh no,
strip
I
the-
know. I remember talking about this 2 years ago. So
Yeah.
glad we're talking about it again.
So to capture this, what you do is the procedure is you take the cozy sign one, that's a signed statement. You always scrape entirely the unprotected header, and then you have the to be registered bytes.
Yeah. And it
That's
matters a
the
lot
consensus.
when you're dealing with like multiple receipts also, because you need to, if you have detached payloads, you need to be able to consistently know what you were dealing with.
Steve, no to be signed.
I'll-
Okay, yeah,
And-
yeah, okay.
And the
Yeah, but that is a confusing phrasing. Why don't you inverse that and say you take the whole signed statement, scrape the unprotected header, and that's your to be signed bytes. I think that's easier for from every point of view.
and I want to get this wording specific because it's important now, because I was trying to remember the NEs are in the protected header and the CWT claims. Technically, we don't support another element here. So if anything was ever added, what would we say the default behavior should be? To include the new element? So that this goes to whether we exclude unprotected header and keep everything that's left, or do we specify it's protected, payload, and signature, and then anything
No. There's a definition for an empty unprotected header, and that is an unprotected : empty map.
Yeah. So what you're
no, I'm not saying protected. I'm saying if we in the future, I'm trying to do a little future proofing, and you guys can tell me that we're right here. It says that you can't add anything else, because right now, if are we saying exclude, or are we saying include these three?
Right now, you're not saying anything, but
Well,
I think what you're proposing is you want to assign names to these things. The way that you intend to assign the name is you want to produce a hash that's consistently the same hash for any given signed statement or receipt. And there's CDDL that you can include that will help you produce that hash. The CDDL will always have the empty map in the unprotected header. So you'll take any existing message, you'll say, whatever this message is, it's the representation in CDDL of the message that will be hashed will have an empty unprotected header. And that's like how you'd very clearly explain that. And that's also why we had those URNs previously. I know, like we talked about that on the list, like the URNs are annoying and you don't want to use them as identifiers and APIs, but the reason to create a URN is to give a consistent name to something, and so that you can say, hey, like this is the name for the signed statement when referred to by reference. And then you can always remove the unprotected header as part of producing that URN, and then you'll always have a consistent name no matter what you're talking about.
Take this message, clear the unprotected header. Yeah, so clear. So now I think Amory, the question of Amory highlights that it can be phrased a little bit more on the point. Take the existing matches, replace the unprotected header map with an empty map. I think that's the most error-free way to say it, I guess.
Yeah, I mean, you're creating an identifier, and when producing that identifier, you take a signed statement and you replace the unprotected header with the empty map, and you compute the SHA-256 digest of the object. That's it. You're describing a procedure to create an identifier that when people follow this procedure, they always arrive at the same identifier.
Yeah. We are talking about identifier for signed statements, and everybody seems to be on the same page. Are we putting this into this text? Because this is news to me that everybody agrees on that.
No, I think no one will agree to it. We've been around this loop already once, like a year ago.
Okay, so we are silently ignoring that.
Right now, I'm just trying to put notes for this discussion, and then I'm sure we'll have a debate on the actual PR. But
no. So URN, we don't have to define a URI scheme for URNs. It's fine. But this has to go somewhere. The default behavior of a registration includes depth item item 1. There's only one. And so yeah, then if that is to be going into the text, that's fine with me. Anybody does not want this to go into the text.
I think we do need to clarify this. I don't even think Michael understood the question he was probing at, and it just the further I try to reread that section, I realized we hadn't clarified it. You guys didn't capture. You didn't answer my question though, and I just want to make sure. Right now, we can only have 4 things in the map.
What? This is an array. This is an array.
That's an array, and the unprotected header property. In this case, you can see that it has some optional elements.
No, I get that here. I get in the nested structure. What I'm saying is in this structure, what prohibits the fact that we did not specify in this map.
You cannot change what a cozy sign 1 is. You're not allowed to talk about even thinking about changing that shit.
Okay. Because if it was, and that's what I'm trying to clarify, because we're saying is we're going to empty the unprotected header. If anything else was added,
the
then
second element of the array shall be the empty map.
No,
that's what we're saying.
And we are saying you can never add another element to this array.
Yeah, I don't think we need to say that. That's what saying you're using a cozy sign 1 is.
Okay.
Yeah.
Because cozy sign 1 specifically says it's only a 4-element map.
It's an array, but yes.
Yeah, array. Yeah.
And the order is important, which is.
Yes.
I found it interesting because I realized in my presentations, I was resorting this because it was easier to discuss and show, but the order is very critical.
Oh yeah, you definitely can't change the order of that. That's what using a standard cozy sign 1 means.
Okay. So is this capture our notes well? Are people fine with this?
It's only in the context of, so this is the context of what goes into the ledger, and it's not about assigning the identifier piece. This is just about telling people like the normalization procedure for every signed statement before registration.
But it doesn't say what we stored in the ledger. We intentionally did not put what had to be stored in your unique implementation of the ledger.
Yeah,
because you're okay with serializing the signed statement the way you've normalized it, the hash of the value, or and then additional data to show that you actually evaluated it. But we've never written down for each individual implementation what has to be in the ledger.
Yeah, I would just call the procedure normalization of signed statements prior to registration, right? Like that's agreeable text. It doesn't say what you're actually storing. It just says this is how you normalize before you register.
What does the storing mean to you? Storing means the actual signed statement, right?
The original comment somebody made was what goes into the ledger. And
okay, and this is into the ledger go the to be registered bytes. The procedure how to create the to be registered bytes is defined as replace unprotected header with an empty map.
No.
Correct, but we never state what gets written into the audit log.
Okay, I don't know what a ledger is then.
Yeah, so the input is a cozy sign 1. Before processing it, you shall set the unprotected header to be the empty map. Then you may apply the registration, policy, which is out of scope for this specification.
Okay.
What the receipt will reflect will be the normalized sign statement plus any additional information as required by the registration policy. And the receipt will always be for all of that.
Good. Okay, that's very straightforward. So you can add a timestamp, for example, as per the registration policy.
Yeah, so I mean, this is the whole thing is like people are like, well, what if I put other stuff in the unprotected header after making it the empty map? So I could set it to be the empty map and then I could put timestamps in there.
Yeah, exactly.
And like that's your registration procedure, but the standard normalization is to set the thing to be empty. And then additional whatever changes can happen. Because we don't say what's going into the actual like ledger, we can't tell you what's actually in the receipt.
That's the receipt format specified in the alternatives in the other specs.
I'm sort of given up on the idea of specifying any of that at this point.
I mean, I think you set the demarcation line pretty well. You are saying the to be registered bytes are created by taking the sign statement, replacing the unprotected header map with an empty map, applying the registration policy, which could add all this stuff back in.
Exactly right.
Then put it into the tree. Fine. And the magic happens and policy are getting applied, and you have to specify policy and make them somehow available, ideally through the same transparency mechanism, and then we're good to go.
Well, the registration policy that was applied would be in the receipt.
Yes, I assume so.
Maybe
there was a discussion
not.
about that.
Why?
Like, it's
Yeah, so there was a discussion that a receipt, and I think Roy also wanted that at some point, that the receipt should indicate the policy in effect at time of registration of that statement, the receipt as well. Yeah,
that's an indirect marker, yes, but we never got to there because we took it out.
And we can immediately create a guidance or a profile to SCITT that would elaborate on that after we are done here with this document. It doesn't have to be here. If the baseline can't agree on it, it can be a winning profile. I don't know. And so that doesn't matter.
The interesting original question was, given a signed statement or a transparent statement, how do you compute what the ledger looks at? And then the question that keeps popping up is, do we specify what has to be written to disk? And now we've never listed that written to disk has to be the same for each instance in implementation. And that was intentionally done. But we didn't even cover the basis of what the key to go audit-wise should be. And to me, it's exactly this normalization process value that is the key.
Yeah, because if you take a signed statement and submit it and strip the unprotected header, now the client that submitted it knows what that is, right? They just know they stripped the unprotected header.
Anyone can compute the identifier. Anyone can compute what was stored in the verifiable data structure. Given they're holding the object, you can always know what was stored in a verifiable data structure when you strip the unprotected header.
But now what I thought I heard you guys say is the transparency service could stick a timestamp or something else in the unprotected header and then record that.
Right. Without some BCP 14 language in your proposed standard that says you must set the unprotected header to be empty. You may not add additional properties to it before recording it in the verifiable data structure. Then you're being permissive of the registration policy making changes, and then the normalization procedure is like sort of basically irrelevant because your registration policy actually controls what goes in. So this is like the whole loop we've been in on this whole thing for some time. It's like there is a way to sort of be concrete about all of this and sort of take all the optionality away, but it requires basically saying you must do these things and you not leaving any room for, you cannot treat the unprotected header as an extensibility point and define a normalization procedure. You need to pick one or the other.
Agreed.
And that's why I'm getting caught in this loop. And I don't know if it was Roy that suggested it. So I'm just trying to figure out who brought it up and how do we resolve it. So I think we're saying you cannot, are we, you should not, okay, I'm trying to be careful. Could, should. Go ahead, Omri.
So I just want to say that there's space to put stuff in the protected headers of the signature that's done by the ledger. So this is where, for example, we put our timestamps. And that's nice because it's very clearly authenticated in a very direct way by the ledger signing stuff saying, yeah, I signed this stuff and these facts are true about the things that are signed. So there is an extensibility point if you want to, add information about submissions and things like that. And, using the unprotected header as this is indirectly signed in a tree and so on is not the only way to do it, that's for sure. And I think is less clear and less direct than in the protected header for the signature. I make these statements. It was this time, it was that time, when this happened and so on. So there's a good place to do this already.
Wait,
and it's not that.
How do you put the timestamp in the protected header? Because the protected header was already signed.
So what you missed here was, given a signed statement, we generate a cozy receipt. The receipt is a cozy structure, in which case we're going to put in its protected header the timestamp. We're not putting the timestamp.
Oh, so you're not modifying the timestamp you're not modifying the protected header of the original signed statement. It's the receipt signed statement. I got you.
That was the simple thing that Omri's pointed out, right?
So that's not recorded on the ledger, but if you
Correct.
keep the receipt.
Yeah, that's not recorded on the ledger, but it's asserted in the signed receipt by the notary system or the ledger operator, whatever you want to call it.
How do you prove? So if I don't have the receipt, how do I prove the timestamp?
Well, you go to the transparency service.
Which timestamp are you talking about?
The registration timestamp.
You can't, because a receipt is the only thing that proves registration anything.
You can get order.
So if I lose that receipt,
you get order out of the audit log, but you can't get necessarily the same time.
Yeah. So if I lose the receipt and it's gone, then the only thing that is left is it's between two other timestamps, hopefully, that other people own. So you only know the ordering, as you said.
But Roy's right, like from an audit log perspective, like let's say I have full read access to your entire ledger, all of the bytes on disk you use to store your data. And I have a signed statement in the wild with stuff in the unprotected header. And I want to know, was this registered ever? I do the normalization procedure. And if you've implemented the normalization procedure, I get a hash, and then I just look in your data structure. And if I find that hash, I know it was registered at some point in time. Now, I still don't know what chronological time that I don't know what chronological time that registration applies to if I don't have other information. But I do know that this signed statement was included in this ledger before these other signed statements and after these other signed statements. That's a thing that I know.
Also you can realize that it's registered 20 times.
Correct. If it was registered, if the same thing was registered multiple times, you would see duplicate entries.
Yeah, exactly. And the actual bytes submitted to the registration procedure could have been different in every of these 20 cases.
Correct.
But you will never know.
That's right.
Good. If that's a baseline everybody is comfortable with, that's going into text. I want to see that in text.
All right, so just time check. We're at the hour. I'm going to hit comment. I'm going to hit commit on this comment. Does anybody want to take the pen for this PR?
Yes.
Hank, is that yes? Somebody. Do you volunteer?
I will declare victory on this stupid thing finally.
You have been so dubbed and assigned. Okay, thank you. And thank you to Michael for surfacing this ornery question. Calendar wise, we'll take proposing we take the next 2 weeks off between Christmas and New Year's, give everybody a well-needed break, not setting expectations of doing anything, and we will pick up in the new year. There's a whole bunch of other feedback from Michael. It was really good. So if you're bored and done opening presents on Box Day, if you want to look at something, that would be helpful. And I've opened the relevant issues that I thought were actionable, including this gnarly one. So thank you very much for a great year, and I'll see you folks in the new year.
Likewise. Have a good transition.
We still have time for that.
Have a Merry Christmas, everyone.
See you later.
Wow.
See you later.